Hi, my name is Shaheen. I'm going to show you how you can use prediction software to bring the power of predictive analytics to Internet of Things. I'm going to use a Raspberry Pi for this demo. The Raspberry Pi is a single board computer, which is a small device that can run computer applications. I'm going to use prediction to predict the maximum temperature of a CPU over the next 5 to 10 seconds. All of the calculations are going to take place on the Raspberry Pi. I will also share the results with a dashboard that is running on Azure websites. Let's start with the dashboard. This is the real-time results of the predictions from the Raspberry Pi. As you can see, the Raspberry Pi is reporting its CPU usage, current CPU temperature, as well as the predicted maximum temperature over the next 10 seconds. I can trigger a computationally intensive activity on the Pi, which will increase the CPU usage, and therefore the CPU temperature will start to increase. And so does the predictions for the temperature in the next 10 seconds. In other words, the Raspberry Pi is using its current state to predict its situation in the future. This is a simple example of Prediction's ability to easily embed predictive models onto a device to support challenging use cases presented by the Internet of Things or IoT. Let's see how it works. Prediction provides a powerful and innovative platform to create and deploy predictive models into production environments. In this case, we have built a model that predicts the temperature in the next 10 seconds based on the CPU and the current temperature. Predicting the temperature on a device is an example of an important metric to support business-critical use cases such as predictive maintenance and asset utilization and optimization. I can simply click on Deployment Assistant, choose my desired inputs and model outputs, and get the required files for deployment. I'm going to skip the details of model creation, which is not the purpose of this demo. I would rather show how such model will work. The trained model is deployed using an MLSM file or machine learning semantic model, together with a lightweight runtime environment. The Raspberry Pi is an example of a device that runs the prediction runtime and uses MLSM to do detached execution or device scoring. Once the runtime and MLSM are transferred to the device, the sensor data is used as input to the predictive model and predictions are obtained. Notice that the runtime is completely independent of any changes in the model or the data structure, so there is no need for changing code in case you have a new model. This extremely flexible architecture allows deployment on any device that has Java or .NET runtime environments. On the Raspberry Pi, I'm using the Java environment. The prediction platform also provides a REST API, which would allow for even more flexibility in solution architecture. The predicted temperature is then sent to a dashboard application in the cloud, which can then be triggering some action or make a decision based on the predictions. It can also send a command back to the Pi to control the CPU usage. So what you see is a simple example of a predictive model running on a device making decisions in real time. In this case, the platform is a Raspberry Pi, but the possibilities are endless. Thank you.